Okay, so eventually we'll get more in depth about the normal distribution, which is actually very easy, and we don't need advanced math, but it's in our calculator. Really doing stuff by hand is kind of some advanced math. We have to have numerical methods in the calculator, which we do, and the normal distribution in reality is only done on the calculator later. I can't help but get a little bit off topic. Yeah, later we're just basically going to have two, which are inverses of each other. They call it normal CDF and inverse norm. So that's all that's going to come later as far as the normal distribution. Yeah, but whenever we introduce the normal distribution, that's for exact values on our calculator later. Whenever we introduce the normal distribution, it's all about the empirical rule. So the easiest way, it's not really a way to calculate it. We just do some of the most basic calculations. Yeah, the easiest way to present the normal distribution in the beginning is through the empirical rule. So let's talk about the normal distribution. We do this now. So this is a normal distribution. We're trying to do it nice and neat. We're going to talk about the normal distribution, and we're going to talk about the empirical rule, and it's a mound-shaped, sometimes referred to as a bell curve. But this is the normal distribution. Yeah. I don't want to talk too much about it. It just becomes a giant lecture, but there's kind of two that overlap, the normal distribution and the standard normal distribution. Let's go ahead and do the standard normal distribution. Sometimes just to make a very simple point clear, we just say it over and over again, which I will. Yeah. And that's the fact that a z-score is, what is a z-score? Define a z-score. A z-score is the number of standard deviations above or below the mean. So with a normal distribution, the mean is always in the middle. So for z-scores, the mean is actually 0. Okay, so the mean, if something is exactly normally distributed, it's really good because you have a lot of things in the world that are approximately normally distributed. So you can use a normal distribution. But if something is literally exactly normally distributed, the mean, the median, and the mode all equal the same number. So the normal distribution is symmetric. It is a mirror image about the middle axis if that was a y or something. It is exactly symmetric, yeah. And then the mean, median, and mode are all in the middle, and it's that right there equals 0. So I don't know if I'd call it a sophistication. It's supposed to be introductory math, but people do pretty well, like an A grade or an A or a B on this stuff, and they still don't really know what it means. But with all these distributions, including the normal distribution is the single most important distribution. With all of these, there's literally a number line down there. So the area is a probability. A probability is an area is a probability. It's hard to teach it coherently. Yeah, but it's the probability that we're between two values. So the area is a probability. Probability is an area. Yes, but the actual values are going to be down here. So there's a number line down there. So all normal distributions, they don't change. The basic concept behind the normal distribution does not change. We have the mean, median, and mode all in the middle. They're all the same thing. We only say mean, but I don't have to say it over and over. The mean equals the median and the mode, but we don't talk about those. We only talk about the mean, which is all three at once. That's always in the middle, and we always have, this is the definition of a normal distribution. We always have exactly 1, 2, 3 standard deviations. 1, 2, 3. It's all the simple little things in math that we can't really explain very well. Let me just erase all that there. But this is 1, this is 2, and this is 3. This is -1, -2, and way over there would be like -3, yeah? Way over there is going to be a -3, so okay, so like I was kind of saying before, yeah, like I was saying before, uh, A z-score is the number of standard deviations we are above or below the mean. So this is one standard deviation here. Yeah, and the standard deviation equals 1. But if z, for example, equals 1.2, it literally means we're exactly 1.2 standard deviations above the mean, yeah? So if z equals negative 2.5, it does mean that we are exactly 2.5 standard deviations below the mean, yes? Okay, so we talk about all of this, the normal distribution and the standard normal distribution. Every little piece I'm not describing, it's hard to say the entire thing in great detail. Already, I tend to talk, very fast, but if we describe every little less detail with this thing, it would just take too long. We've described a lot of the basics, but it is true the standard normal distribution where the horizontal is in z-scores. Yes, it is true that this is the standard normal distribution, which is in z-scores. It's always the mean in the middle, then 1, 2, 3. Yeah, standard deviations above and below. The standard normal distribution always looks like this. Okay, good. So we haven't talked about the empirical rule. All we've done is defined what this is. So this is specifically the empirical rule, yeah? So in between plus or minus 1 standard deviation is going to be exactly 68% of our data. Yeah, it's only 2. I mean, in the end, what are we talking about? They call it the empirical rule. Some people call it the 68, 95, 99.7 rule. Yeah, that's what some people call it. But remember the probability that we're in between, we say that, remember the probability that we're in between two values, but even though it's not as if we've taught it yet. Yeah, because we do the empirical rule every little thing. It's not like we teach it backwards. It's just people don't really know what we're doing. But the shading is the probability that we're in between -1 and 1. We're just saying, according to the empirical rule, sometimes if I pause, it's just hard to manage this system here. Yeah, okay. So annotating the screen. Okay, so the area is the probability is the area, and there's a 68% chance, or we also say 68% of our data is in between plus or minus 1. Yeah. Okay, so what about plus or minus 2? So this is plus or minus 2 standard deviations from the mean right here, yeah. So we can erase a lot of stuff if we want. We have a lot of options when we're kind of doing it this way. I make all these lines, but yeah, plus or minus 2 standard deviations is going to be all of that. And that right there contains 95% of our data. Well, I can't say all of it. I'll never be able to say remember all of it at once, and it wouldn't help anyways. But there's like 5 different ways to say the same thing. If we say the probability that we're in between plus or minus 2 standard deviations is 95% or 0.95 probability, that's true. If we say that 95% of our data is between plus or minus 2 standard deviations, that's just saying the same thing. So uh, it's completely understandable that in the beginning, students don't necessarily know what we're talking about, but we just have to slowly understand this, yeah? So 95% of our data is in between plus or minus 2. Yeah, we don't have to do a perfect job here, but okay, so plus or minus 3 standard deviations. There's only 3 numbers with the empirical rule. This is the empirical. Yeah, plus or minus 3 standard deviations is basically shading the entire thing, and specifically it's 99.7% of our data. So we do call it the 68, 95, 99.7, yeah. Between plus or minus 1 is 68% of our data. Between plus or minus 2 standard deviations is 95% of our data. Between plus or minus 3 standard deviations is 99.7% of our data. Yeah. So it's very easy, the empirical rule. Now we have some things. I'm going to make a really complicated It's just kind of the area and how good we are at geometry and graphing and all of that. In a way, geometry and graphing are kind of the same word, yeah. But we're not paying attention to this example. Let's kind of do something really complicated to show it. But they can make kind of like little puzzles or brain teasers or like little IQ questions out of the normal distribution and the empirical rule. So remember, this is like in between plus or minus 1. That's a 0, that's a 1. This is like in between plus or minus 2. Yeah, 3. And then we don't have to draw this thing for perfect. It only goes plus or minus 3. How long does all, not this one, they're all the same definition. How long does all normal distributions go for? They go for 6 standard deviations. Yeah, they go, if we have plus or minus 3, the entire thing is 6 standard deviations long, that line down below. That does go for all normal distributions. They're all the same definition. So they can literally ask us, they can ask us, what's the probability that we're between -2? Yeah, what's the probability that we're between -2 and -1 standard deviations? That notation I just did up in the corner is not like any kind of a recognizable thing. We're just talking about this here. Yeah, tapping all over the screen, making mistakes. So they can say kind of a little thing. What's the probability? What is that shading? Find the shading is find the probability. Find that shading is find the probability that we're in between those two values. Yeah. Okay, so what is the, let's just kind of do this. What is that middle that I didn't shade? Yeah, the middle that I didn't shade, this entire thing is 68%. That's what that is. Okay, so what is plus or minus 2 standard deviations? Plus or minus 2 is 95. So we should see instantaneously that if we do 95 minus 68, we get just those 2 bars that are shaded. Yeah, so 95 minus 68 is just those 2 bars. Yeah, so we're starting with a hard one just to make a point. Yeah, if we do 95 plus or minus 2 minus 68, yeah, plus or minus 3, we get those 2 bars. So now if we do those two, it is symmetric. It's symmetric about the middle. Yeah, which means if you take 27 divided by 2, we get 13.5%. So 13.5% is just one of those things there. So the bigger minus the middle divided by 2, because it's symmetric, we get that. So we start off with a really hard one just to make that point that they kind of make a bunch of puzzles out of this thing, yeah? Or sometimes they keep it really easy, but they could make a puzzle. Okay, good. So we kind of do this here, yeah. So whenever they kind of give us one of these, they do like a fairly easy one here. This is the example. Uh, we don't usually make it this long and flat when I'm just kind of trying to conserve room. But in the beginning, it's a very good exercise to label everything. So remember, only the standard normal distribution, which is written in z-scores, has 0 in the middle. Any actual word problem, all of them have the mean in the middle. Yeah, but this is going to have a different number. The mean is 246.9. Yeah. And a standard deviation of 68. So remember what that means is that this length, this value here is not 68. It's 246.9 plus 68. Yeah, so this length, what are we saying? The standard deviation, this length is 68.8. Very easy, but people struggle with it, which is okay. We don't mean to give anybody a hard time. But if we label this, we just add 68.8 3 times, we subtract 68.8 3 times. So if we understand this stuff very well, we can skip all of this. I'm just saying, if we're really making a lecture and doing the problem in totality, we're always supposed to draw a normal distribution. We're supposed to label it mean in the middle. We have to add 3 standard deviations. We have to subtract 3 standard deviations. So we're just adding 68. And like I said, a lot of people don't even understand there's a number line right there, but we have to know that. Yeah, so it varies quite a bit. But the first thing is we can kind of read the word problem, but there's always kind of a, the context of the problem is what they're actually talking about. But usually we can just pull out the numbers. Part A is what is the approximate percentage of women with palates, blah, 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 within 2 standard deviations of the mean or between those 2 values. Yeah. So they give us the thing here. Oftentimes we have to find it, which is what part B is, but they just straight up tell us within ±2. So we know from the empirical rule that that's 95. We don't think about that. So then B is kind of more of a problem. What is the approximate percentage of women with palate counts between 40.5 and 453.3? Yeah. So math, very easy, but what do they say here? 40.5 and 453. Yeah, this one over here. Okay, so they just give us ±3, therefore 99.7. All of it is just straight up empirical rule. All of it is actually way easy than drawing and labeling the thing. So it's all very, very easy here.